When you start R, you'll see something like this at the console. Boilerplate information about the current R installation. Mine is a bit out of date. The first thing that I want to show you is just what I mean by giving instructions and receiving output at the console. So here I've run a single line of code, 3 plus 3, and that is represented at the console by this greater than sign and then 3 plus 3. This doesn't actually mean anything is greater than something else. It just indicates the beginning of a line of code that I ran. And the output is presented in a different color, and you can ignore this part for now. The answer is 6. When you issue a simple instruction like this, R carries it out. And if you don't specify what to do with the result, it will default to printing it for you, right there in the console. One of the most important kinds of instructions that we'll use is variable assignment. Here's an example of that. This instruction gives no visible output, but it does something really important. It creates a variable named x and stores the value 3 in that variable. The arrow thing is called the assignment operator. If I was to print x to the console after this line of code, then it would reveal that the stored value in x is 3. So the arrow takes the result of the right-hand side and stores it in the name on the left-hand side. Here's what happens if you try to access a variable that doesn't exist. There is no variable called y yet, so R tells us object y not found. But if we create a variable called y, then we will be able to see its value. So now I have assigned the value 4 to y, and when I print y to the console, I see that it does contain 4. You can do arithmetic involving variables. For example, when I print x plus 1 to the console, I see 4, because x, the stored value in x, is 3. I've used the variable x in this expression in place of its value. Y times 2 is 8, because y is 4, and x plus y is 7. The arrow is not the only assignment operator. You can also use a single equal sign to assign a value to a variable. For example, here I've specified that z should be 5, and now the name z refers to the value 5. Both assignment operators are valid. The arrow is more commonly used, but I like the single equal sign. It's more convenient and more similar to other programming languages. Use whichever one you want. I will use both of them in this class. Variable assignment replaces the old value of a variable, if there is one. So if you want to change the value of a variable, you can just assign to it again. X is still 3 from before, but if I assign a new value to x, 6, then now x is 6, and 3 is completely forgotten. Variable names can be longer than just one letter. The key thing about the left-hand side of the assignment operator, the creation of a new variable name, is that it is a valid name, a label that refers to an object that R can store in memory. You can use any string of letters as a variable name. For example, here I have assigned the result of the mathematical operation 2 plus 7 plus 1 to the name turtles. And turtles is just the name of a variable that now has the value 10 in it. Names in R are case sensitive, so capital T turtles simply does not exist. We used lowercase t turtles for the name of this variable. Names can also have numbers in them, but they can't start with a number, or else R will think that you're trying to type the actual number. Names can also have underscores and periods. In general, you should start names with a letter. The comment character in R is this pound sign. The R interpreter will skip everything after that character in a line of code. Use comments to make headings in your code file and explain what you're doing. You can put a comment on its own, or you can put a comment at the end of a line of code. For example, here I have assigned the value 6 to x by adding 3 plus 3, and I have a comment at the end of the line of code explaining what I did. That comment does not affect what the R interpreter does when it sees this. And I can print x to the console in the same way, with a comment at the end of the line explaining what I did. Basic arithmetic works about the way that you would expect. The order of operations and the parentheses are consistent with standard norms. So the result of this operation is 9. X, the stored value in x is 9, because 4 plus 2 times 7 is 4 plus 14, which is 18. And then when you divide that whole thing by 1 plus 1, you get 9. The caret is the symbol for the exponent operator. So this represents x minus 3 squared, which of course gives 0 because 3 squared is 9. If you don't finish a line of code, then the console will prompt you for the rest of it with a plus sign. For example, here I type x and then a slash, which is the symbol for division. And I'm not done, I haven't finished my statement yet, right? The instruction is clearly not complete. And the R interpreter knows that, so the plus sign just means that it's waiting for me to finish that statement. When I finish it with a number like 2, then I get the result. X divided by 2 is 4.5. This only happens when it is clear that the line isn't done yet. Many programs feature lines of code that actually take up more than one line in the script file. This can be very handy when you have long lines of code and you would like to keep them organized. Here's a longer example. I have turtles plus turtles plus turtles plus turtles plus turtles. And remember, turtles was just 10. So if it stopped there, then it would have given me 50. But because there's a plus sign at the end of that first line, it continues on the second line, and I add the remaining 5 instances of turtles to get a total of 10 of them, for a total of 100. Now, of course, if I really wanted to multiply this variable by 10, I would just use the asterisk for multiplication. But this illustrates why it might be convenient when you have a long line of code to split it into multiple parts, as long as each part ends in such a way that it's clear that it's not actually done yet. Here's an example of a simple function. Functions have names just like variables. To use a function, type the name and then parentheses. The parentheses indicate that it's a function and also contain any input that you want to give the function. sqrt, for example, is the name of the function that calculates square roots. When you're making your own variables, try not to use names of things that already exist, like this function. So sometimes it's useful to check to see if a name is in use already. If I need a variable to contain the square root of something, maybe I would be tempted to call that sqrt. But if I type sqrt on its own at the console, I see a brief definition of that function, rather than seeing error sqrt not found. And that should be a warning to me that sqrt is already something important. I don't want to reuse that name for something else. But square root, all spelled out, is a perfectly acceptable name. When I type it at the console initially, I get error object square root not found. So I can assign that the result of some mathematical operation, in this case, calculating the square root of x using the sqrt function. And now square root is a variable that contains 3. The input values of functions are called arguments. So in log of 100 here, I've got the log function. Log is the name of a function that takes a logarithm. And I've got the parentheses. And in the parentheses is one number, the number 100, that I'm using as the argument to that function. And the log of 100 is 4.6. The second argument to the log function, which I didn't specify there, is the base of the logarithm. So if I do log of 100, comma 10, then I get 2. The comma indicates that I'm moving on to another argument. The first argument is the number to take the logarithm of. The second argument is the base to use for that logarithm. So of course log base 10 of 100 is 2. You may also specify arguments by name, rather than having to just know that the base of the logarithm is the second argument. I can specify base equals 10 to make it explicit that 10 is supposed to correspond to the argument that is named base. So far, all of the variables that I've showed you have been numeric, but you can also have character strings as variables. So here I'm going to assign x the value ASDF. I used quotation marks to indicate that this is supposed to be interpreted as a character string, not the name of something else. And now x contains that character string. You can use single or double quotation marks for this purpose.